Let's have a look at exercise 5. So the question is, how much memory is required for a given picture on a computer or TV screen? And as you know, it's about the resolution, the number of pixels we do have, and the color depth. That means how many bits per pixel are required. And two values are given. The first is full HD for the resolution, and then color depth of 16 million, which is the same as 3 byte per pixel. So what is full HD? Full HD is the same or is specified as 1920 pixels times 1080 pixels. So you have 1920 in the horizontal and 1080 in the vertical dimension. How do I know? I have simply looked it up in Wikipedia. And for the exam, you don't have to learn these numbers. I will either give a table or I will give the values in the exercise as such. Here for the exercise, you should learn to be able to use Wikipedia or other sources for information. Now, how does the calculation look like? So we do have 1920 times 1080 pixel, and we do have 3 bytes per pixel. And now we can simplify, we can get the pixels away, and the unit is then byte, which is good because we are looking for a file size. So we can continue, and we have a simple calculation of 1920 times 1080 times 3 byte, and again a calculator is of help, so let's type it in. We have a 1920 times 1080 times 3, and we get a big number. And now, of course, 6 million is not the right answer. You should bring it down to kilobyte or megabyte. So as we have file size, we have to divide by 1024. We do it once. Now we have 6075 kilobytes, and we divide once more by 1024, and now we have roughly 5.9 megabyte. So this is equal to 5, or let's write it a little bit better, 5.9 megabyte. Let's move it aside, and now think about the same for the movie. So now we need some more information. We have these kind of pictures, 5.9 megabyte, and we do have quite many of them because a movie is simply a collection of pictures, and we have now 90 minutes, and per second we do have 24 pictures. That's what sometimes called frames per second. So 24 frames or pictures per second. So how can we now do this calculation? We do have these again, 1920 times 1080 pixel per picture or per frame times 3 byte. 3 byte per pixel times 24 pictures per second times 90 minutes times 60 seconds per minute. And again, we can simplify. You get the pixels away, you get the picture away, you get the seconds away, you get the minutes away, and the bytes will remain. That's what we are looking after. So again, we can simplify it a little bit. This is 1920 times 1080 times 3 times 24 times 90 times 60 byte. And again, I will use a calculator. So I will have 1920 times 1080 times 3 times 24 times 90 times 60, and you can see it's a relatively high number, so I'll divide it by 1024. We have kilobyte divided by 1024. Now we have megabyte. I divide it by 1024. Now I do have gigabyte. So we have roughly 750 or 751 gigabyte. So this is equal to 751 gigabyte. And if you compare this number with the numbers you have on a DVD in usually, so you have roughly 2, 3, 4 gigabyte, which a movie of this size takes, then you can see that our figure is much too high. Now the calculation which we have done is correct, however we haven't calculated the compression, and the compression here is really very strong, so it gets down the figures by a factor 100 or even more.